So last time we just stop here. We started to try to focus on double integral over general regions. The general region here is different from the rectangle region because if the area is a rectangle, it's easier for you to just change the order of the integration. For example, in this case, you can easily change dx dy into dy dx. Okay, just simply change the limits AB to CD and CD to AB. Okay, this is for rectangle region. But for general region, actually it is not a rectangle. Normally, it will just bounded by like y is equal to g2x and y is equal to g1x. That means the region will be bounded by these two curves. Then for the x direction, we will follow x is from A to B. So this is a general region. So in such a case, the general form should be like this one, okay? Because your region is bounded by these two curves and also these two constants. So you will integrate with respect to y first, then go for x after, okay? So last time I also show you an example that in the beginning, maybe the questions are this, the expression of the integration for you first, but you need to have the ability to change the order. But if you want to change the order, the best way for you is just try to draw the region first by the expression. So normally they just give you this one. Then if you try, you can see for this one, we will integral from x first, then y, right? So as I suggest you last week, I hope for example, if this dx, you can just put s equal to y, s equal to 1 in front of y and 1. It can just help you to understand the construction of the region. Then if this dy, so just put y is equal to and y is equal to into these two limits, then it also can help you to understand the whole region. So once you get this one, just remember you can see ds go first. ds go first means small portion x times the function value. So as I told you, function here, I just show the integration region. So actually the surface is just in the air. Surface is here. Surface is here. But this part is just focused on the integration region. So if you see, so inner part will go first. Inner part will go first. So if you see ds, so that means let's just follow small x times the function value. So you can see the function value will be, for example, function value is here, function value is here, function value is here. I mean, this point is the function value, this point is the function value. So we just use the function value times small dx. So small dx, that means we just follow x direction first. We just follow the x direction first. So you can image that that will go for from s is equal to y to s is equal to 1. So gradually you can collect this slice. So this is this part I want to calculate. Then after you know how to calculate this slice, you can gradually collect all slices from y is equal to 0 to y is equal to 1. Okay, so you need to confirm region first. Then if you want to change the order, so we will go for this one. This time we will go for y direction first. So y direction first, you can understand that if both for y direction first, you will just follow this, follow the vertical line first, right? So you can see dy means small portion in y direction times the function value. So this time, function value is here, function value is here, function value is here, function value is here, times small portion dy. Then you can get the area, the area for this small piece. Then gradually collect the small pieces, then you can have whole slice. Okay, so this red one is just want to express, you try to get the area for this slice. Then finally, you will gradually collect all slices from s is equal to 0 to s is equal to 1. So that's why I just ask you, or just suggest you to add the variable here. That can make you easily understand the scope. Okay, then after you convert this from here, you can get this one. Then you can change the order to get this one. Then finally reformulate the expression of the integration. Then here it's easier for you to calculate the integration. Then finally you can get a result. Okay, so these procedures are very important for you to solve the problem if you want to change the order of the you want to change the order of the integration. 那这个是非常典型的一个例子哈。等一下我们还再举一个例子，但是这个部分呢，请大家务必要熟悉哈，熟悉这个过程，也跟告诉大家，期末考这一定会考的。好，但是我们不会去考三个纬度的啊，3个纬度可能担心半个小时算不出一题。因为那个顺序一换，你可能要有3个纬度的思维，但是也不用担心3个纬度的想法跟这一模一样。我现在讲的这些想法，为什么我又重复再讲一次？因为包含我们等一下会遇到，可能今天没办法哈。如果我们遇到的是一个极坐标的系统的时候，它的原理其实都是一模一样的哦。所以这个第一个让你感受到这个原理的部分，一定要把它搞懂哦。所以一开始呢，他也不会给你这些什么 s 等于什么，我会建议大家把它加上去。那加的方式就是，反正这种多重积分一定是内部优先算。那对什么积分，对不对 ？ds 先积分呢，你就最近的这个积分符号的这个边界从 y 等于1，从 y 到1呢，就请你补上那个 x 等于的符号。这个有助于你去了解这个曲线是从哪里到哪里，然后再来这边有 y， 对不对？先这个积分完以后，再对 y 积分的时候，也补上这 y 等于，但做久了你就不用像我这样做了。但是初期如果大家不是很熟的时候，我建议这样子的话，比较容易让你去建构这个积分的区域，了解吗？所以从这个通常题目给你的时候，它只会这个图是我画给你的。在考试的时候，或者是在解题的时候，这个图也是要让你自己从这个表示式呢，去得到这个图的。你可以确立到底它积分的区域是哪一块。所以我们再不厌其烦再讲一次哈。好，这个 ds 大家可以看 ds 代表什么？沿着 x 方向积分。所以从这里从内部这边看到 ds， 知道它是用 s 方向积分，代表什么？它一定是水平线，水平线就是这边有 dx， 因为这个方向我们都知道 ds 是沿着 s 方向一点点的变化区域嘛，对不对？所以大家来解读这个式子的时候，这是一点点的 dx， 去乘以它的函数。哦，照理说这个函数应该是有 x 有 y， 但是这个就是只有 x 而已。所以呢，沿着这个 x 呢，这个方向呢，逐一的把每一个 ds 去乘以它的函数值，函数值就列在大家的这个半空中就对了。哦，那把它乘以这个，我就可以知道它是一个小小的长方形。大家就想一想，就回到单变数函数的时候，这个曲线长在这里，然后这个函数高度就乘以一点点 dx。所以如果你里面的算出来之后呢，代表什么？代表你是在建构这一串的面积，把它累加起来。那最重点是在哪里？你要看到它 s 等于 y 到 s 等于1。所以这为什么要请大家补上 s 等于，你就把 s 等于 y 画出来，起点是 s 等于 y， 终点是 s 等于1，对不对？所以你就知道它是从这里到这里，从这个 s 等于 y 起点到终点是 s 等于1，而不是这边，对不对？因为它终点是 s 等于1。如果今天是 s 等于0到 s 等于 y 的话，那么它就会是这边哦，对不对？如果它这边是0，这边是 y 的话，应该是从这里开始 ，s 等于0开始到 s 等于 y， 但是它是 y 开始到1，所以为什么这个补上去的动作对你讲很有帮助哈？好，那这个算完之后呢，你已经这个构面这个 slice 的算法你已经会算了之后呢，接下来dy 哦又来了 ，dy 就代表什么？沿着 y 方向，对不对？沿着这个 y 方向，慢慢的去收集每一个片段，对不对？所以这个橘色的片段是这个，那你由 y 慢慢的从这里，从这么长，再来慢慢的依序的把这个每一段呢，把它收集起来。那从哪里开始呢 ？y 等于0开始，一直到 y 等于1结束。所以如果这个图你画出来了，这个成功率就一半了哈，因为你已经确切知道它要被积分的区域是这一块，积分区域是这一块。然后呢，接下来换顺序代表什么？我要 y 先开始嘛。记得，如果是 y 先开始，代表什么？垂直的方向，所以就对这个区域呢，画一个垂直线，叫 dy 嘛 ，dy 就是一点点的 y 的宽度呢，去乘以它的函数高度哦，一点点的 y 的宽度去乘以它的函数的高度，一点点 y 乘以函数高度，一点点 y 乘以函数，你就知道这一片的面积是怎么算的，也就是红色的这一块。然后呢，这一块红色的的时候呢，接下来是 dx 是什么？看到 ds 就知道它是沿着 x 方向，从0开始，一直到1结束，对不对？哦，从0开始到1结束，那就变成这个积分的式子。那我再讲一次的原因是，等一下我们介绍这个整个法则，跟我刚讲的这些原理都是一样的哦，都是一样的。那只是不过我们再把上一次的例子再检讨一次，那相信大家应该就更熟悉了哈。Okay, so let's just continue. Okay. Okay. So now let's just continue. So right now, I just want to list the algorithm to calculate double integral for your reference. So we are trying to find the limits of the integration. when we just face evaluating double integral f of y dA, then we focus on some region R. So region R means here. Region R means this one, or this one, or this one. Okay, so region R means you just focus on this region to calculate integration for this function. Okay, then the first step, so if we just integrating first with respect to y, so y first, right? Then respect to x. So you can see if respect to y first, you can just image that will go for dy first. Then with respect to x, then we will go for dx. So you can just image. If we just integrate first with respect to y, that means dy will be the inner part. Then dx will be the outer part. Okay? So the step one, for the step one, we need to sketch the region R. So just like I show you here, right? We need to measure the area of the integration first. So for you need to sketch R first. So for example, I just show you the example that if the region here we focus on is from, for example, normally they will describe what R is. So for example, in this case, it is enclosed by s squared plus y squared is equal to 1. So actually it's a unit circle, but we just focus on first quadrant. Okay, then give you the second curve is s plus 1 is 1. So this is a slanted line. So with this unit circle and this line, you can just measure the area enclosed by these two curves. So you can just sketch the R first, like this one. Then the step two, because we just integrating first with respect to y. So as I told you, so respect to y, so that means that will be the vertical line, right? Here, let me just show you again. So if dy goes first, then it will just pass in the region through a vertical line. So you can see here, so if step two, we just integrating first with respect to y first. So we should try to find the y limits of integration on R. So in this case, we already know the region, right? We just follow the step one. Okay, measure the region. So for the step 2, we still draw the region here. But this time, because find the y limit, dy first. So you just emit a line passing this region. Because it is find the y limit. So please just draw a vertical line from bottom to top. Okay? So this is the dy first, right? So we can find, we will have an enter point. And we will enter at this point at, because originally this is s plus y is equal to 1, right? Originally, this is this one. Then, because right now we just want to find the y limit following this vertical line, so we need to know the enter point. What the enter point is? So enter at. So you can convert it into y is equal to 1 minus x. So enter at y is equal to 1 minus x. From the low point to upper point, right? So this is the enter point. It is y is equal to 1 minus x. Then the leaving point. Then this is the leaving point. So leave at. So originally, this should be s squared plus y squared is equal to 1, right? So we can also get y is equal to positive square root of 1 minus s squared. So that we're leaving at y is equal to square root 1 minus s squared. So you can see this is the entering point, this is the leaving point. These 2 points is the y limit. So with this, we can just get this one first. So that means following this direction, we are trying to get the area of the slice first, right? So if we collect all area from this direction, small dx times the function value, small dy times the function value, small dy times the function, and then you just collect them together, then you can get the area for each side. Okay? Then the step 3. For step 3, we will try to find the s limit of integration on y on r. So I can continue to draw this for your reference. So right now we still focus on this region, but now we already know how to collect this slice, right? Then we can collect them from s is equal to 0. So for s is equal to 0, we will have this point. Then gradually we collect here s equal to 1. Because you can see s from 0, then here, then here, then here, then here. This is a typical one, right? Here, and finally we will stop at s is equal to 1. So we can just gradually collect the small portion, small slice. Then after we collect all, we just finish the integration. So with the help from these figures, then finally we can get the integration as double integral, then f of xy, then we go for dy first. So y will be from y is equal to 1 minus x to y is equal to positive square root of 1 minus x squared. Then this is the first step, right? This is the first step. That is talking about this part, right? Then dy, dx from s is from 0 to s is equal to 1. So for this part, we are talking about to trying to collect all small slice, then sum them up, and finally you can get the whole result. So you can just try to image it if we just go for S first. If we go for S first, the line will be changed from vertical line to horizontal line, right? Horizontal line. Then after you know how to get the slice for following the horizontal direction, and you just gradually collect all horizontal slice, then make the integration completed. So if you can understand the idea, then you almost understand the most important part for this chapter. Okay? So, okay, so let's just go for the second example. Because as I told you, this part is very, very important. So in the beginning, so for example, if the question is just like this one. 4s plus 2 then dy dx. Okay, so we just make a comparison. If dy first, you can see dy first. So please just put y is equal to here. Okay, then dx, so please put s is equal to 0 to s equal to 2. Then this is the function value. So here you can see here is the f of xy. Then we can start to draw the region by, so you can see this is s, this is y. So you can see dy first. So you can just image that later on. Once we finish the region is somewhere here, right? But since D1, so you can just, your first line will be D1 first. So your line will be following the vertical line, right? So your region is here, since it's dy first. So you will emit the sum line which is parallel to y-axis. Then we need to start to construct the region. Y is equal to s squared. So y is equal to s squared is here. This is y is equal to s squared. Then the end line is y is equal to 2x. So it will be something like something like this. This is y is equal to x. Then dy first. So the region will be enclosed by y is equal to x squared and y is equal to 2x. Then dy first, right? So we can get the region dy first, so we can know how to calculate the slice for this small portion. Then we go for dx, right? Dx that means from s is equal to 0 to s is equal to 2. So this is s is equal to 0 to s is equal to 2. So we can measure the region is here, and your dy go first, and then this is dy first, right? Then this is dx. Right now, if we want to change the order, the function is still 4x plus 2 is still the same, but this time we will go for dx, then dy, right? So then you need to try to answer this 4 question mark. So you need to fill out this 4 question mark. So then you try to dx, right? Dx. I just make it smaller so you can have a whole picture. So if so, I just redraw a region for your reference. So the region is still here. It's still this one and also this one. Still this one, right? But this time we will go for dx first. dx first, so that means you need to emit a line which is parallel to x-axis. Okay? So this is dx. Then we start to know when is the entering point, which the enter point is, which point is for the leaving point. So this is the entering point. This is the leaving point. Then we will go for this one first. So originally here is y is equal to originally this line is y is equal to s squared. So right now we need to change it into s is equal to positive square root of 1. So we need to change y is equal to blah 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 x into s is equal to blah 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 1. Because this time we will go for s first. So this is the entering point here. Then leaving at originally this should be the leaving point. Leaving point is here, so this is the leaving point. And enter at originally this is y is equal to 2x. So you need to change it, become s is equal to y over 2. So this is the enter point. So the start point, we s is equal to 1/2 y to s is equal to square root of 1. Right? This is the enter point. S is equal to 1, and you will just leave at original E is y is equal to x squared. You change it as s is equal to positive square root of 1. So you can see always s is from blah 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 to s is always from blah 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 because we will go for s2. Then after that, we know this portion. Then we need to start to collect from here, 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 right? So we need to know here. Originally, this is y is equal to 0. Then here, this intersection for y is equal to s squared and y is equal to 2x. So this is y is equal to 4. That is not that hard for you to understand that because you can just 2x, these two. Okay, I can show you how to get the 4. You can see here, we need to simultaneously have y is equal to s squared and also y is equal to 2x. So you can have s squared is equal to 2x, then s is equal to 0 or y s is equal to 2, right? So you can make sure here is s is equal to 2, and at the same time, the point y is equal to s squared, so is 4. So this, you can get this one, right? Y is equal to 4. So then y will be from y is from 0 to y is equal to 4. This is the final result. So you can see from here, we can have this first, measure the region, make sure they go for dy first. So we will focus on this region. Then we just change the order. So we just focus on s first. So we just emit a ray which is parallel to x-axis. Then we need to make sure which point is the entering point, which point is the leaving point. Then change from the original y is equal to blah 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 x into s is equal to blah 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 y, because this time we will go for x first. Then after that, we just collect following the y direction. Y is from 0 to 4. For the 4, it is easy for you to get the intersection here is 2, 4. This point is 2, 4. This point is 0, 0. So you can easy to know y is from 0 to y is equal to 4. So you can reconstruct the integration form. Originally is this one to this one. So you can just notice that once we change the order, these 4 parameters are totally different from this one, these 4 ones. Okay, so this change the order for the general regions is not that easy because you need to use these 4 parameters to make sure the region first, then change the order to, then finally you can get this new one. Okay, so this is for session 2.这边不是很容易懂，不过你做几次，你就会熟悉。而且我跟大家教大家就是一个技巧，就是对谁基本注意看它题目给你的时候只会白色的部分包含这个往上看一下， 只会像上面这个白色的部分而已。哦，有颜色的部分都是我自己补上去的。那补的方法很简单，就是谁先这边就补 y， 谁后这就补 x。哦，因为 x 后嘛，哈。那你用这个去建构这个积分区域，而且它 dy 先，所以它一定是一个水平，一个垂直线射向这个区域。好，等我们讲到3度空间的时候，它就会变，大家可以想象，现在是二重积分，3重积分的时候，它会怎么？有 x 有 y 有 z， 你的积分的区域就不再是一个平面上一个区域，它可能是一个3维空间上面的一个 region， 它不仅有 x 有 y， 它还有 z， 所以它的谁先，这个原则都是一样的，谁先你就是沿着那个走，比方说 y 先，你就先对那个区域画出来之后呢，沿着 y 走，往那条线线那个区域射。如果是 x 先，一样的也是从 x 方向先发射一条线经过这个区域，都是一样的原理，只是3个变数的时候会让你看得更混乱。哦，那我们期末考我们讨论过，我们不考到3维空间，但是我们很快带过去。然后期末考的话，我们大概敲定了，就是因为今年的速度好像有稍微比去年的速度可以有快一点点，所以我们多考一部分啊，就考那个 Jacobian 的转换是14/8。期末考我们考到14/8，但是不用担心，中间有3维的那波，我就讲过去，你听一听就好。那个就不考，但是 Jacobian 的坐标转换的部分呢，我们会考到2维的。同样的3维我们也不考啊，3维的话那个矩阵当然你们没办法去算啊，就基本上我们就会考到2维的，都在2维里面就结束了，但是3维的部分就介绍就好哦。但是其实所有的原理都跟我现在讲的这个内容是一模一样的，谁最里面谁先做，谁最里面就是你那个走向线往那个区域发射一条直线，经过那个区域，经过那个区域的时候，你只要注意到从哪里进去，从哪里出来，从哪里进去，从哪里出来。好，把握这几个原则，接下来就看看你自己够不够细心了。好 ，OK。Then we shall continue to move to session 3. Session 3, we will talk about the area by double integration. So you can see area by double integration. So we are talking about double integration, but we just use double integration to calculate area. So in the past, when we just calculate this one, actually we are just talking about the, or maybe I can just use the slides here. So you can see, we just use the double integral, but we just calculate the volume, right? Based on this region and based on this surface, this integration is talking about the volume under this constraint, under this function, under this constraint for the region. But can we just use the double integration to calculate area? So that's the topic which we just want to focus on in this session. So when we talk about the area of bounded region in the plane, if we just simply set f of sy is equal to 1 over r, then all set, then the area is equal to double integral on this r, first on 1, then dA. So you can just have a simple comparison with this one. Double integral r f of sy dA. So you can just see, I just force f of sy as 1. So that means no matter sy is, sy is, your function variable is always 1. Then we can just use this one to calculate the area. You understand that? Actually, based on this, we are still calculating the volume. So supposedly, the unit should be it's like a volume unit, like cm3 立方公分。But I just force the function value as 1. So that means no matter, so you can just image that this one. If I just force f of sy is 1, so that means no matter at which point, your function value is always 1. So finally, actually the area size is same as the volume size. 所以休息前最后做一个总结，我们就强迫这个函数 f of sy 等于1，在这个 r 上面的话，那当我们在计算这个注意哦，这个双重积分事实上是在算体积的，所以照理说它出来应该是一个体积的单位，cm3次方公尺3次方。可是由于我这边强迫它为1，代表什么？这个曲面每个高度都在那个点都是1，所以算出来纵然它是一个体积的大小，跟它的大小是跟它的面积是一模一样，因为每个地方长得都是1，所以请跟它做一个比较。所以它是大小一样，但是事实上它算的事实上也是一个体积的大小，那这个大小会恰好等于这个 r 的面积大小。我们先休息一下，好，接下来再继续这一块哈。So as I mentioned in the previous hour, that actually we just try to use the double integral or double integration to calculate area, which is bounded by some straight line. So you can just image that in this case, so you can see if I give you the region S, Y, then Z, right? If the region defined as here, this is the region R on in the XY plane, right? So how can we just image that? That is talking about that. Okay, I just force f of sy is equal to 1. So that means no matter at which point, the height is always 1. The height is always 1. So you can see actually they are trying to calculate the volume. The volume, even though we are talking about how to calculate volume by this integration, but actually the size is set as the area of the region. Okay, so you can just try to image that. Actually, we are talking about that. So then I can give you a example about this. That please just find the region, the area of the region R, which is bounded by y is equal to x and y is equal to s squared in the first quadrant. So this is example. Okay, so try to find the area of the region R bounded by y is equal to x and y is equal to x squared in the first quadrant. So I just hope you can just have a comparison of this. So for S, we need to draw the region first, which is bounded by y is equal to s squared and also y is equal to y is equal to x. This is y is equal to x. So this is the region, right? So just image that this part is here, right? So for each point, we just make its height as 1. All of them is 1, right? So what we need to do is construct the integration. So this is, so for this, we can try to get the integration for these 2 points. How can we just get it? 1. We can just have y is equal to s squared and also y is equal to x happen at the same time. So we can have s squared is equal to x. Then we can factorize them to have this one. So s is equal to 0 or 1, right? So we can understand that s is equal to 0 is this point, and s is equal to 1 is this point, right? Then we also can get y is equal to 0, then this point is y is equal to 1. Right? By using 1 as an input for either y is equal to x or y is equal to x squared. So we always can get the y value as 1. Okay? So once we just know where the region is, then the next step is try to construct the double integration. So the area A can be defined, can be expressed as double integral. Then it depends on, you will go for dy first. You will go for dy first, then dx. But the integrand is always 1. Always 1 means at all points, every point is high. Always is always 1. Okay? But you can see in this expression, I just go for y first. Right? So right now I believe you already know the tip, right? If we go for dy first, that we just emit a rate which is parallel to y-axis, right? Toward this region. And we need to know where is the enter point, where is the leaving point, right? So in this case, we will enter at y is equal to s squared. This is the entering point. Then we will leave y is equal to x. This is the leaving point. From here, enter point through several dx, small dx, small dx, small dx, then reach the leaving point y is equal to x. So we can put y is equal to s squared to y is equal to x. Right? So we just finish the inner part. Okay? Then we need to collect following the y direction, x direction. So x will from 0 to 1. So we can put s is from 0 to 1. Okay. And I'm not sure if you still remember, in last semester, we also learned this before. Next time, we just regard this is the upper curve, this is the lower curve. So at that time, we just learned that before, that integral from the upper one is x minus s squared, then dx, s is from 0 to 1. So this is we just learned last semester. Did you remember? If we just treat it as a single variable function, right? So this is the upper curve, this is the lower curve. We always take the gap from the upper to the lower. So this is this one, s minus s squared, then times small dx. Okay. So let me show you. This is trying to calculate the difference. Then trying to calculate times small ds. Right? ds is here. This gap times small ds. This gap small ds. Then collect then together by using the Riemann sum. Right? So the difference here and here is, here we just treat it as a single variable function, two single variable function to construct the region, right? But here we treat it as a the size is the same as the volume size when we force f of y is 1. Actually, these two ones are the same. I mean the result are the same. 上学期的时候，这个题目呢，其实用这样记就可以。上学期的时候，我们比较单纯的看上面的是谁，减掉下面，去算这个差距，然后从积分从0到1，然后算出来就可以了。这是上学期所学的。这学期呢，我们学的是，我们利用一个就是把它函数强迫为1，然后呢，利用双重积分去算出它的体积。那我讲体积事实上是它的体积是算出来确实是一个体积，当然它的大小呢刚好跟面积是一模一样。那我重复这样讲是又顺便带到，如果这是3个变数的时候会变成，本来有 dx、dy、dz 对，如果强迫是1的话，我就会变成是算它的体积了。我给你一个 region， 那这个 region 的体的大小是什么？我强迫它是1。如果是双重积分，我强迫它是1的话，我算出来是它的面积。如果是3重积分的话，我就强迫它是1的话，那就是我要的体积，那个积分区域的体的大小。所以这个都可以顺便把3维的3重积分呢，顺便从这2维的把它给衍生过去。Okay, so I think it's not that hard to understand that. So if we want to calculate the average, value of f of sy over R. It will be defined as area of R so we can reformat it as divided by right. So if you don't if you still remember that for the single variable we also learned this before. I hope you still remember that if this is y is equal to fs, and starting from a to b, if we want to get the average number, average value, it is defined as integral from a b fs dx over b minus a. So this is for single variable function. But I just hope you can just make a comparison. This is for single variable function. If you want to calculate the average, we are talking about, we just calculate the area first. Actually, I cannot say it's area because you know the function could possibly positive or negative. So we just try to calculate the equation first from A to B, divided by the length of the interval. Then you can get the average value. So it just extend the idea to two variable functions. So for this part, we just calculate the volume first, divided by its area. Okay? Just like here, we just calculate the area first, divided by the length. For two variable functions, we just get the integration first, divided by the area. Then we can get the average value for f of sy over R. So I can give you a simple example that find the average value of f of sy is equal to s times cosine sy over R, which defined is bounded by s is ranging from 0 to pi and y is ranging from 0 to 1. Okay, so in this case, we can just draw the region first. This is simple, right? Because region here defined as s is from 0 to pi, and y is from 0 to 1. So you can just understand the region R is here. So if we want to get the average value for f of sy is equal to x times cosine xy, so we just follow this. Average is equal to double integral s times cosine xy dy ds. Since it's a rectangle, so you can just simply put the region, the s ends and y ends here. So for this is y ends first. So y will go from 0 to 1, then S will go for 0 to pi. Then over the area of the region, right? For this part, it's simple, right? Because it's a rectangle, so you can just simply use the width times the height. So it will be height times 1. So through some calculation, let's give the detail. Okay, because the region here is a rectangle, so it's easy for you to carry its size. You don't need to have a complex integration to get the result. So you can just simply use pi times 1 and get the area of the region. Okay, then I will give you another example which is more complex than this one. So please find the area of R which is enclosed by y is equal to s squared and y is equal to s plus 2. So I believe you already know how to solve such kind of problem, right? For you, just construct the region first. Construct R first. So we should draw the region first. This is sy. Then we will have y is equal to s squared and y is equal to s plus 2. Then this is the region. This is the region. So for you, you can also, you can also use the method we learned last semester. You can regard it. You can just get to end. So we can solve this to end by s squared, y is equal to s squared, and y is equal to s plus 2. So with these two conditions, we will have s squared is equal to s plus 2. So we can continue to move s squared minus s minus 2 is equal to 0. Then we will have s minus 2, s plus 1 is equal to 0. So we have s is equal to 2 and negative 1, right? So this is s equal to negative 1 to s is equal to 2, right? So at the same time, you can also get this point is equal to this point will be, because this s is equal to negative 1, so the height will be 1, right? So y here is y is equal to 1. Then you can also get this point is y is equal to 4, right? Because you can just use 2 and say the height is 4. Okay, so there are several methods for you to solve the problem. The solution one Solution 1. For solution 1, if we just emit, if we just go for y first means, okay, let me just show you. If we try to construct the double integral, then we go for dy first. So d1 means we just emit a ray which is parallel to y-axis toward this region, right? So d1 for this, we just emit a ray following this direction. Then we need to find its enter point, which is, this is enter point, this is leaving point, right? So enter point will be y is equal to s squared to y is equal to s plus 2. Then the integrand is 1, right? Because I just want to get the area. I'm not talking about the volume. I just want to get the area. So focus on 1. Then the enter point is y is equal to s squared. Then leaving at s plus 2. Y is equal to s plus 2. Then we integrate it with respect to x. So x we have from -1 to s is equal to 2. So the result is 9/2. Of course, I just give some detailed calculation. I believe you can do that by yourself because the integral is 1, so it's easy. Okay, this is solution 1. And if we use solution 2, so we still draw the region. Again, this is y is equal to s squared. This is y is equal to s plus 2. Then we know this is -1. This is +2. And here is y is equal to 1. And then this is y is equal to 4. Okay? So this is for y first. But if I just want to change the order from y first to s first. So s first, you already know, if I go for s first, we will emit a ray which is parallel to x-axis, right? Supposedly it should be this one. But please just notice that, you can just notice that here we will just enter at the depth part for y is equal to s squared, then leaving at the right part of y is equal to s squared. But if you just lower the ray here, here we just enter at this point and leaving at this point. So let me just show you. This is the region, right? So in this case, this one and this one is different. Did you notice that? This ray just enter at y is equal to s plus 2, but leaving at y is equal to s squared. But if your emitting ray just follow this one, you will see they just enter here to here. So you can see this enter point is different from this enter point. Okay, did you notice that? Please just notice here. Just pay attention here and pay attention here. So the A here will be divided. A here will be divided into two parts. But we always go for dx first. Also focus on 1. Then dy. But right now, we need to, okay, there are two parts. One is focused on we need to change this as here is s is equal to positive negative square root of y, then here is s is equal to positive square root of y. So this is the this will be the enter point from s is equal to negative square root of y to s is equal to positive square root of y. So right now, I just focus on this part. So you can see from enter point is s is equal to negative square root of y, and leaving at s is equal to positive square root of y. Okay, this is this part. And this part will from s is equal to y, s is equal to y minus 2, because we need to reformat the line become s is equal to y minus 2. Then the leaving point is also s is equal to positive square root of y. Okay, so this is this help. This is this help. Then for this help, y will range from y is equal to 0 to y is equal to 1. Then for this part, it will be 1 to 4. Okay, so I just put y is from 0 to 1. Then here is y is from 1 to 4. Okay, am I correct? Yes, correct. And the final result is still 9/2.好，来，我们这个看起来比较复杂一点啊，我再解释一下。这个图呢，要怎么看呢？因为这次我是用水平的，那水平线射过来的时候，你会发现它其实 会有两种情况。如果低一点的时候呢，它是从抛物线的左半边进入这个区域，从抛物线的右半边离开这个区域。当超越了 y 等于1的这条线以上的时候呢，你会发现它进去的点是这条线，但是离开于抛物线的右边。所以这个如果你要用 S 线积分的话，你必须要注意到它会被切成两块，一部分是这个抛物线的左边进入抛物线右边，一个是从直线进入，然后从抛物线离开。所以你就要建构两个积分，双重积分，对不对？好，我们来一个一个看哈。我们先看下面这一段好了，从抛物线的左半到抛物线的右边，这边算出来之后呢，要沿着 y 开始收乘，对不对？那 y 会从0开始到 y 等于这条线，超过 y 等于1之后呢，它会是这个 y 减2，哦，注意哦，这个本来叫 y 等于 s 加2，当你要从 s 线积分的时候，你要把它改成 s 等于 y， 所以就会从 s 等于 y 减2到 s 等于 y 等于9点开根号，然后呢，从哪里开始呢 ？y 等于1这条红色的线，就叫 y 等于4，收起来。哦，所以这是 solution 1、solution 2，对不对？当然，我们刚刚有讲的，其实还有个 solution 3。Solution 3 will be A. We just treat it as a single variable function that integral from -1 to 2. Then the upper is s plus 2 minus s squared, then dx. That is still this one. So there are 3 possibilities. But for you, you know, if we have the similar, something like that. So since we just learned the double integration, so if we have a similar question for you, you cannot choose this one. You should use this one. Okay? But before you choose solution 1 or solution 2, you can just have some judge. Following S first is better or following 1 is better. In this case, following y first is better. 就是说大家可以去比较一下 ，solution 3基本上在这个学期我们就不考虑了哈，因为这是属于上学期的解法。当然上学期其实相对也很简单，对不对？相对很简单。但是呢，这学期呢，我们现在学的双重积分，当然就希望大家用双重积分解法来做这个问题。好，那我们就回到 solution 1跟 solution 2。那 solution 1跟2来说做一个比较的时候，大家重点就先把那个 region 画出来。画出来之后，随着 x 线还是随着 y 线呢，你自己可以做个判断。判断什么呢？如果以这个例子的话呢 ，s 线的话，你只要一个积分式子就做出来。y 线，但如果是 x 线的话，你就要小心，它切成两块，因为它的离开跟进入的离开的曲线是不一样的。哦，那这边你就计算两个双重积分式的积分，但是答案应该都会一模一样啊。So this is for section 3. Okay, then we still have 10 minutes. So maybe I just slightly introduce the session 4. Then I will just give you a very brief introduction to you. And then uh, next Monday, we will go to the detail. For the session 4, we were talking about double integral in polar form. So what is polar form? Did you still remember? You can see here, we just construct the region by uh, y is equal to blah 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 x, or x is equal to blah 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 y, right? So we just construct the function, the curve are totally constructed by x y axis. But if we just talk about the polar form, then you can just imagine that the region will be constructed by the polar coordinate, based on the polar coordinate. So we can just image that if I give you this is x, y, then z, right? So if I give you z is equal to f of x, y, then if we try to calculate the volume, so once I give you the z is equal to f of x, y, and then I force you to focus on y is equal to g1 of x to y is equal to g2x, then s is from A to B. So the region will be here. This is a general form, right? General region, right? So in this case, maybe we just focus on, for example, maybe the curve will be something like this. Then you are trying to get the volume. So the volume can be calculated by V is equal to double integral f of x, y. Then we can integral with respect to y first. So y will from g1x of x to y is equal to g2x. Then dx, right? S is from A to B. So we already learned that, right? In the previous 3 sessions, especially for starting from section 2 and 3, we know how to calculate this one. So we are talking about the volume. But if we just force f of x to 1, then we are talking about how to calculate the size of the area for the region. So this is just what we learned before, right? But now, today, we will move to polar form. So following the same idea, so let me just draw the similar picture again. This is y, this is x, this is also z, right? But this time, the function here will be given by z is equal to f of r theta. So please just make a comparison here and here. Before, the function will be given by z is equal to f of y. But this time, I give you z is equal to f of r theta. So that means we just change the coordinate from sy Cartesian coordinate to polar coordinate r theta. So still the same that once I give you z is equal to f of s1, we can just try to understand that it's also a space service, right? It's still a space service. Once I give you z is equal to f of r theta. But this time, the region is defined in different way. This time, the region will defined by theta is from alpha to beta. Then R is from R1 G1 of theta to R is equal to G2 of theta. So the region defined here is by theta is equal to alpha to theta equal to beta. Also confined by R is equal to G1 theta to R is equal to theta. So the region is here. So once we just map the region onto the service, so you can see the service may just look like that, something like this. Maybe not that correct, but anyway, you can understand that, right? We are also talking about the volume, right? We are trying to calculate the volume V is defined as f of r theta. Then R1, R is equal to G1 of theta to R is equal to G2 theta. Then alpha is for dr. Then the theta will from alpha to beta. In polar form, we just have the order dr first and d theta. But it's very special. We need to add an r into the integrand. So that means you can just have a comparison. This is a simple. This is just the function f of s1. But if we focus on the polar form f of r theta, we need to add an additional r here. So that means the whole integrand is this one, compared to this one is this one. But today I don't have time to explain why we need to add r. So next Monday I will explain why we need to add r here. So please make sure that once you just encounter a polar form like this one, remember to add r here for your integrand. 好，这边很快讲一下，但是这部分就下礼拜一再讲哈。先给大家一个很大的比较，上面是我们从14之1到14之3所学的，很简单，就是积分是这个被积分的函数 f(s1)。但是呢，如果你遇到这个极坐标的形态的话，就是函数给你的也是 z 点 f of 但是它这次不是用 sy 表示r西塔表示的时候呢，一样的，它也会有一个曲面出来。这个曲面也是在空间里。那同时你也可以把你的 region r 画出来。这个 region r 通常是西塔的 alpha 开始到贝塔，但是呢，在 r 的方向是由这个 G1 西塔到 G2 西塔去限制出来的，所以就会有这个区域。所以通常我们在算这个重积分的时候，也是在算这一块的整个体积。所以很类似，你会发现很类似。唯一不同的地方是，如果你的是一个 polar form 的话，积分的时候，除了这个是指 你要多一个 R， 多一个 R。好，这是第一个，这下礼拜一再跟大家解释。第二个，它一定只有一个顺序，就是对 R 进行积分，它是细盘进行，不像那个 DX、Y 哇，它没办法。哦，它一定是 DR、DC 那这个概念延伸到三维坐标的时候，其实它也是类似的东西。那三维坐标我们拿到球状和柱状做出来，哦，那部分会跟大家会做介绍。但是今天先让大家先了解这两个这个初步的不同。那下礼拜一来的时候呢，跟大家介绍为什么要这样子打。Okay, so let's just call it a day. And see you next Monday.